Hello everyone. In this video, I'm going to explain how to search a mathematical model in BioModels database, how to download model files, and using Copac, we'll see how literature results are reproduced. So let's first visit the BioModels webpage using web address www.ebi.ac.uk/biomodels/. This web address will land you to BioModels homepage, which shows multiple options and features provided by BioModels. Now, if you have a particular model ID, you can always go to the quick search option and search your model ID. If you don't have a model ID, you can always go to the list of manually curated models and try to find the models of your area of interest. Now, since I'm focusing on a particular model file for which I have an identifier, I'm going to download the model files associated with that model identifier. So what I'm interested in is a model done by Kolodenko in year 2000, where he's talking about the MAPK signaling cascade and the impact of negative feedback loops on MAPK cascade behavior. So now once you go on the model page, you'll find an overview which actually contains the information about the model identifier we just used to search this model. Then we have a short description which talks about what this model is and what it contains. Then format, where in which format the model has been submitted, the primary file, which we know it's SPML and level 2 version 4. The associated publication with this model and who has contributed to this model. Now file section has all the files with this. The main model file is under the model file area and additional file is under here. Now we'll try to download the main file because this is what we're using in Copac to explore the model. So I'm just quickly downloading it. Also, history contains the revisions of all the modification that has been done, and the curation tab contains the curation figure and also the setup that has been done to recreate this or reproduce this curation figure. Logically, which figure has been reproduced, what software has been used, what pathway, what markers has been reproduced. So this all our information will be there in curation commits. So now, as I told, I'll be using Copac to open the model. So you can always go to visit copac.org and download the Copac depending on your OS, whether it's Linux, it's Windows or Mac. To learn more about Copac, go to support and try to see the video tutorials, manuals and other things so that you can learn about Copac. Now, since I have already pre-installed Copac, I'm just going to open it. Yeah, and I'll try to open a new file. So basically, since we have downloaded a SBML file, we'll go to this import SBML option and try to open the model file. Now, once you download the model file, you have a basic information about time unit, about the model, basically a short description, different annotations that has been used for it, associated model PMIDs, also details of what all compartments has been used, a species, which is basically a protein, RNA cell, it can be anything which is as dependent on the model. Then we have the details of reactions here. Now to simulate the model, basically we need two information. First, a time course information, which basically needs for how long we have to simulate this model. This information we can extract from the paper, associated paper, which explain about how much should be the simulation time. So if you see, we try to reproduce the figure 2a. So if you'll see here, this is simulated for around 150 minutes. So we'll try to do the same in our simulation results, time course result, and we will, since this model is in seconds, we'll try to convert the minutes into seconds and give the simulation time accordingly. So once we set the simulation time, we need an output specification, logically what we want to plot. So if you see the literature figure, we are logically plotting map K, which is phosphorylated, and map K, which is non-phosphorylated form. So we're going to define the same in the plots. So what I'm interested is in on x-axis, I want to plot model time, and on y-axis, I want to plot phosphorylated map K, and similarly a non-phosphorylated map K. Now, both things are done. We are ready to simulate, and we'll do the simulation. So this is my simulation IP results for ERK phosphorylated and ERK non-phosphorylated. And if you see the simulation results, it's very similar to what is given in the literature result. And this is how we reproduce the results. Thank you for watching this video, and see you soon.